In this video, we will introduce Intelligent Plant's alarm analysis software. In 1994, the process automation industry was alerted to a problem caused as an unintended consequence of the increasing use of sophisticated computer control systems to run complex processes in the hydrocarbon industries. The 1994 explosion and fires at the Texaco Milford Haven refinery injured 26 people and caused damage of around £48 million and significant production loss. Key factors that emerged from the Health and Safety Executives HSE's investigation were: there were too many alarms and they were poorly prioritised. The control room displays did not help the operators to understand what was happening. There had been inadequate training for dealing with a stressful and sustained plant upset. In the last 11 minutes before the explosion, the two operators had to recognise, acknowledge and act on 275 alarms. Paragraph 69 of the report states that warnings of the developing problem were lost in the plethora of instrument alarms triggered in the control room, many of which were unnecessary and registering with increasing frequency, so operators were unable to appreciate what was actually happening. Recommendation number 6 suggests that the use and configuration of alarms should be such that safety-critical alarms, including those for flare systems, are distinguishable from other operational alarms. Alarms are limited to a number that an operator can effectively monitor, and ultimate plant safety should not rely on operator response to a control system alarm. This led to a publication in 1999 by the Engineering Equipment and Materials Users Association, Alarm Systems, a Guide to Design Management and Procurement in the UK. This guideline gives extensive advice on how to ensure optimal performance from an industrial alarm system. Despite this, 15 years later, there are still many poorly performing alarm systems, risking not only a major incident, but contributing to minor trips and upsets that will have a significant effect on a plant's bottom line. The loss to industry in the US alone is estimated at $10 to $20 billion annually. Why did the problem arise? Originally, dials and switches were located very close to the plant they controlled. This moved on to centralised control rooms, like that on the left, which had many indicators and switches that were hardwired. Space is limited, so each must be justifiable. Adding a new alarm would mean removing an existing one. Because indications are physically placed, they have a context, left, right, up, down, etc. They will be beside other relevant information. The whole process could be seen at once. With modern computer systems, like that on the right, we can have as many alarms as we like at very little cost. A few mouse clicks will create a new alarm. Many systems were specified with everything to alarm, just in case. This is what led to the situation in Milford Haven. These are the 7 steps of alarm management. Computer systems exist to monitor alarm performance and deliver key performance indicators, KPIs. However, little has been done to actually diagnose the problems. Intelligent Plant have developed IP alarm analysis to not only tell you that you have a problem if you have too many alarms, but to also help you through the process of rationalising them by supplying detailed analysis and indications how to change to alarm configuration. This was the first tool which generated EEMUA 191 3rd edition reports, and the only tool that's been designed from day one to do this across your enterprise. The main KPIs are shown in a clear and intuitive manner. Bad actors are calculated and displayed. In subsequent videos, we will see how to use alarm analysis in detail.